Last week we started Ohm's law. And I told you a lot about Ohm's law. And today we are going to extend our study in Ohm's law to Kirchoff's law. Kirchoff's law is just an expansion of Ohm's law so that we can use the Ohm's law to solve complicated circuits. In Kirchoff's law we have first law and the second law. Now let me explain to you Kirchoff's first law. It states that the current entering a junction is equal to the current leaving a junction. That is, if this current is I, and it enters this junction, you have I1, I2. And according to Kirchoff's first law, it means this current entering this junction, I, is equal to I1 plus I2. Or it can also be stated as the algebraic sum of current entering a junction is equal to 0. It means that I can be minus I1 minus I2 according to this equation we have here. So this will be equal to 0. That is Kirchoff's first law. Let's also talk about Kirchoff's second law. It also states that in an algebraic sum of EMFs in a closed circuit is equal to the algebraic sum of PDs around that particular circuit. So, if we check the circuit I have drawn on the board, it means that the EMF the cell is producing, E, is equal to the potential difference across the circuit, that will be I, R1 plus I, R2 plus I, R3. As we see it in this way. That is Kirchoff's second law. So now we are going to apply Kirchoff's first law and second law to solve this question I'm having here. We have this example on the board, and according to this example we are going to find the PD across 5 ohm resistor. PD across this 5 ohm resistor. So according to this question we have 2 loops. We have loop 1 here and then loop 2 here, which we are going to apply Kirchoff's laws to solve this question I'm having on the board. Now let's consider Kirchoff's first law, which I said current entering a junction is equal to current leaving the junction. If we check this whole circuit, it means I will flow through the 5 ohm resistor. It enters this junction. So I enters, I1 is leaving, I2 is leaving. So I1 plus I2. That is Kirchoff's first law. We are going to apply the second law, which also states in a closed loop, EMF around the loop is equal to PDs across the same loop. According to this circuit, we have 2 closed loops, loop 1, loop 2. And before we apply the second law too, we have to obey a certain pattern. We first give it a direction. So I want to direct my first loop this way. And then I will direct my second loop also this way. Now, we follow this instruction so that current leaving the positive terminal of the cell, we consider it to be positive. The EMF there is considered to be positive. When the current leaves the positive terminal, the EMF is positive. And then current moving in the direction of the direction I have given will also be considered positive. It means if it is leaving in opposite direction to the direction I have given, then we consider it to be negative. Now, let's consider loop 1. You will see that current is leaving the positive terminal, so this EMF 2 is positive, will be equal to the PD across the loop 1. This I1 will flow through the 1 ohm resistor. So the PD across 1 ohm resistor here is I1 multiplied by 1 ohm, which is also I1. PD across this 5 ohm resistor will be I is flowing through, so plus 5 multiplied by the current I. Now, but we have I to be equal to I1 plus I2. So in place of I, I'm going to put I1 plus I2 there. Then we have 2 will be equal to I1 plus 5 I, which is I1 plus I2. Good. Let's finish our equation. So let me continue from this side. 2 will be equal to I1. If I expand this, we have 5 I1 plus 5 I2. If I simplify this, then we have 2 is equal to I1 plus 5 I1 will be 6 I1 plus 5 I2. Then let's call this equation 1. That's why I told you earlier I should go and revise for simultaneous equation. We are going to apply it very soon. So that is for loop 1. Then let's come to loop 2. Loop 2. Here too, we have given it a direction. The direction is given based on your own choice. Then you obey the rules. When current leaves the junction, you follow your direction. It means that current is leaving the positive terminal. So the EMF, which is 4 volts, 4 will be positive, will be equal to PDs across that particular loop. Here we have I will multiply 5, so the same thing, 5I plus I2 will go through this 3 ohm resistor. PD across there will be 3 I2. The same thing, 4 will be equal to 5 I. From Kirchoff's first law here, I will put I1 plus I2 plus 3 I2. If I simplify this equation very well, then I have 4, 5 I1 plus 5 I2 plus 3I2. Then 4 will be equal to 5I1 plus, so I have 5I1 here, then 5I2 plus 3I2 will give you 8I2, and this was will be our equation 2. As you can see, I told you last week you should revise your simultaneous equation. Now, we have got two equations which we are going to solve it simultaneously. The rest is mathematics that we shall go through quickly. In the book, you can get Kirchoff's laws very well. So now let him put down the equations here. From the equation 1, we have 2 is equal to 6I1 plus 5I2. This is my equation 1. And then equation 2, we have 4. Then we have 5I1 plus 8I2. We are solving these three equations simultaneously. You can apply any methods at all that you think is suitable for you. Whether it's substitution method, elimination method, or by matrices. Hope you are doing elective mathematics as well, so you understand matrices. You can apply Cramer's rule or determinant method to solve this. Now, I want us to apply elimination. Let's take equation 1. Equation 1. Let's try to eliminate I1. So to eliminate I1, let's multiply through equation 1 by 5. 2 by 5, we have 10. 6 by 5, we have 30. 30 I1 plus by 5, we have 25 I2. Then let's call this equation 3. Then again, let's take equation 2, we multiply 2 by 6. 4 by 6, we have 24. 5 by 6, we have 30 I1 plus 8 by 6, we have. Let's continue. Now, let's write equation 4 minus equation 3. Equation 4 minus equation 3. So here, 24 minus 10, we have 14. Will be equal to 30 I1 minus 30 I1 here will be 0. 48 minus 25 I2, 48 I2 minus 25 I2 will be 23 I2. Then from here, it rather implies our I2 will be equal to 14 over 23. 14 over 23. Let's write this in decimals. We'll solve it. Use your calculator for it. We are going to have 0.609 amperes to 3 decimal places. We want to get I1. So we can put our I2 into any of the equations at all. Then we can have our I2. Let's put it into equation, let's see, 1. And if you put your I2 into equation 1 and then you solve, then you are going to arrive 2 will be equal to 6 I1 plus 5 I2 represents 0.609. And with this equation, very simple equation, if you solve your I1 from here, then you are going to have I1 to be equal to minus 0.174 amperes. The negative sign we have got here It's telling us that the I1 should move in the opposite direction to the direction in the circuit. That's the reason why we got this negative sign. From the question, we have asked to solve for PD across 5 ohm resistor. So to get the PD across 5 ohm resistor, then it's supposed to be equal to I should multiply the 5 ohm. And to get I, you know that from Kirchoff's first law, I would be equal to I1 plus I2, and our I1 is negative 0.174 plus I2, which is 0.609. And when you add this together, you have your I to 0.435 amperes. And when we have something like this, we put our I, which is 0.435, inside. Then you have, in place of I, we put it there. So 0. So your PD will be equal to 0.435. We multiply by 5. And we are going to have our final result as 2.174 volts. 2.174 volts. As our potential difference across the 5 ohm resistor. As you see, we have applied the Kirchoff's laws to solve the PD across the 5 ohm resistor. And I want to give you some so that as you are going to try, and the next time we meet, you submit it to me. I'll clean the question, this one yourself, and you make sure you submit it to me in our next time we meet. This time round, this one is at 10 volts. I will give out internal resistance to it. Good. I want you to try this. This time round, you are going to find PD across 12 ohm resistor. So this time round, the current given to you is X, Y, and then Z. And you have been added internal resistance to it. Internal resistance for the 10 volts cell is 2 ohms. And internal resistance for 5 volt cell is also 3 ohms. So I want you to solve this question and then you submit it in our next meeting for marking. Thank you.